All right, let's jump right into it. Today, we're taking a truly mind-bending journey in this explainer. We are going to descend from the dizzying, abstract heights of internet math, travel all the way down through the foundational architecture of the web, and actually land directly onto a little robotic toy sitting right on a physical desk. It's an absolutely incredible story about how developers finally figured out how to make pure digital truth violently snap into physical reality.
So, to understand how we actually got there, we have to start with this massive number right here, 402. Now, to most of us, this probably just looks like another random annoying server error. But to internet historians and protocol engineers, oh man, this is a 30-year digital cold case. It's a structural mystery of the web that was just left unsolved for decades, until it was finally cracked wide open at ETHGlobal in 2025.
Okay, let's dive into this. If we trace this all the way back to 1996, internet pioneers, guys like Tim Berners-Lee, actually reserved the HTTP 402 status code specifically for native web payments. And by 1998, it was officially solidified as payment required. The creators of the web knew, even way back then, that we'd eventually need a built-in native way to just pay for things on the internet. But then, absolute crickets. It completely flatlined. There's this massive empty gap until the X42 protocol finally activated it in 2025.
So here is our roadmap for today. We're going to cover the 30-year digital gap, escaping Ricardian contract bloat, the ETHGlobal NYC breakthrough, LIFO single-entry bookkeeping, and finally, physical execution with Cheerbot. We are zooming all the way in from global internet architecture right down to local hardware.
Section 1. The 30-year digital gap.
We really got to address the bizarre reality of this dormant web layer. The source material gives us this absolutely perfect explanation. It literally gathered digital dust for almost 3 decades just because humans don't naturally shop through raw server error codes. I mean, think about it. You and I, we use credit cards, we use monthly subscriptions, Apple Pay, shopping carts, because human commerce is super forgiving and relational. But we didn't have autonomous AI agents browsing the web back in the 90s. We lacked the precise deterministic software that actually needed to negotiate micropayments directly with server code.
Moving right along to Section 2. Escaping Ricardian contract bloat.
So, when developers eventually did try to solve this on-chain payment problem in the early Web3 space, they hit a massive, structurally debilitating wall. They suffered from what engineers call Ricardian complexity. Basically, early developers kept trying to attach these incredibly heavy, bloated 50-page legal text contracts directly to simple digital transfers. It was an impenetrable wall of complexity. The developers of Base's X42 protocol, however, bypassed all of that, using what they brilliantly call the chopsticks design. It's like, imagine you just want to pick up a single piece of sushi. You wouldn't spend a fortune building $1 million hyper-complex robotic arm, right? No way. You'd use chopsticks. They're simple, they're precise, and they're perfect for the job. X42 uses surgical, lightweight webhooks and simple client callbacks instead of those bloated smart contracts.
Which brings us to Section 3, the ETHGlobal NYC breakthrough.
This is the real turning point here. Now, what's really interesting about this slide is the specific pitch from the CoLaw legal engineering team at the physical event in 2025. They stood up and asked, what's the Gold's Law project at ETHGlobal New York 2025? It is the flow kill switch using ERC 7827, and it's the remote control using Base's X42. They somehow successfully combined a strict mathematical state contract with the surgical remote control of the X42 protocol.
The team behind this whole thing, CoLaw, are basically legal engineers who bridge law, tech, and even the music industry. They realized that Base's X42 protocol finally solved the webhook remote control problem they had literally been waiting years for. Combine that with stablecoins, which provided the perfect missing piece for instant digital tips, and they nailed their ultimate goal, spreading what they call Cosmo Cheer through live physical interactions.
All right, Section 4. LIFO single-entry bookkeeping.
So to guarantee a digital tip doesn't accidentally trigger a physical machine twice or just fail altogether, your digital data structure has to be flawless. Enter the ERC 7827 protocol. It introduces value version control, taking standard lightweight JSON, the basic text format we use to zip data across the web all day, and turning it into a rigorous mathematical smart contract layer. And the engine powering this whole thing is a LIFO, or last in, first out state tree. By strictly pivoting to this structure, the very last item entered is the first item evaluated, which completely unlocks highly efficient single-entry bookkeeping.
And this brilliantly illustrates the concept. Imagine a highly efficient bouncer at a really busy nightclub. This bouncer doesn't need to walk down the street and check the ID of every single person in a massive line, right? They only need to look at the ID of the person standing directly in front of them right at that exact moment to figure out the current, absolute state of who gets in.
So the absolutely crucial point here is this number right here, 0. Because of that LIFO bouncer structure we just talked about, a machine only ever needs to query index 0 of the data tree. It gets an immediate, flawless mathematical proof of the system's state without painstakingly scanning massive, expensive transaction histories. There is zero ambiguity here. It is mathematically true or it isn't.
Finally, Section 5, Physical Execution with Cheerbot.
We are finally dragging all of this pure math out of the digital ether and setting it right down onto a physical desk. Meet the Flow X42 Cheerbot. On the surface, it just looks like an awesome, cheerful little 3D printed collectible desktop toy. But tucked inside is a localized Raspberry Pi microhost. And using a Raspberry Pi is a very deliberate hardware choice. It's an accessible, robust edge computing device specifically equipped to bridge software and hardware. The Cheerbot basically acts as a fully functioning robotic switchboard, constantly reading that mathematically pure LIFO index 0 we just talked about.
Let's move to and see how this builds into an exact sequence of physical action. Step 1. The surgical 402 payment webhook is triggered out on the network. Step 2. A cryptographic proof of that micropayment is securely signed. Step 3. The Cheerbot utilizes that single entry bookkeeping to perfectly verify the state right at LIFO index 0. Step 4. The exact moment it's verified, the Cheerbot translates that pure math into raw electrical signals, firing its physical GPIO pins. Literally, those metal pins shocked the bot into action, spinning a motor, turning on an LED, or dispensing a physical item.
We have officially crossed the bridge, guys. From a completely dormant 1996-era code, through surgical X42 webhooks, down to a LIFO JSON tree, right into a spinning motor on your desk. This is digital truth violently snapping into physical reality. So as the web's architecture evolves and these autonomous, agent-driven economies begin to interact directly with our physical world, what role will you play? Are you ready to architect the edge of the network? Thank you so much for joining me on this explainer. Keep questioning the architecture around you, and I'll catch you next time.